And on page 50 in your notes, what I need to begin with today is the part that will be newest. Again, on page 724 in your notes for homework tonight, you're going to be doing more systems of graphing, and it's my goal to try and get to one of those today. But since we've done systems before, if I don't get there, I'm not going to worry about it. The biggest difference in today's graphs are going to be that there are addition and subtraction included with the trig graphs. Now, I've changed, not this equation, but I've changed the next two on this page of notes. So I'm going to scroll down right now and first give you a quick chance to copy the two equations that follow this one, and second, explain the differences between the two. Now, this one, and I'm going to go over this quite thoroughly, has what we're going to call a vertical shift, or an addition subtraction that happens after you've calculated the value of the trig. All that's going to do to the graph is raise it up 4 units. It's going to be the same graphing with the same amplitude and the same frequency and the same period and the same interval. Just take the entire graph and hold it up high. And I'm going to show you the quickest and easiest way to get that graph down on paper. The second equation that we're going to be doing today, I've changed. So cross out the one that's in your notes and put in this one. And this graph is what we'll call a horizontal shift. And that is a shift that occurs right-left on your graph paper. Now, the biggest thing I need you to be able to see as you look at these two equations is how do I tell the difference? And the answer is quite simple. If the plus minus is trapped in a set of parentheses with the angle, with the x, or with the theta, then it's a horizontal shift. If the plus minus comes at the end of all the trig and is detached from the trig part of the equation, then it's a vertical shift. The third graph that I'm going to try to get done in here today has a little bit of both. And so this will be the hardest one. It's got a vertical shift, that's the plus minus that happens after all the trig, and it's got a horizontal shift. That I can tell because it's trapped. Usually you'll see parentheses involved with a horizontal shift. Now, just so we're all clear and all talk in the same language, I've actually inserted a page into my notes that you're welcome to copy, or you can just get on my website tonight and print this page off, because what I'm about to do is kind of give you a quick outline of what all those shifts look like. And I know you don't have this, but you can just watch. I've basically taken the two graphs, sine and cosine, and I've put letters in where you might see numbers. These two graphs, the a sine bx plus c and the a cos bx plus c, are called vertical shifts. Vertical shifts, again, are happening when it's after the trig that I see the plus minus. And specifically, if I see a plus, this set of graphs will move up C units. Whatever C is, you're going to take the entire graph and move it up or lift it up that high. These two are the same exact graphs, these next two down, but instead of a plus, I'm seeing a minus. So for these two graphs, I would take this graph or this graph that we learned how to graph last block and push it down C units. Does everybody see where I'm getting this from? And do you see what I mean by the plus or minus occurs after the trig has completely been calculated? So basically it's just a change in the answer, a change in the y value, a change in the height. The horizontal shifts are a little bit harder because they happen before you actually calculate the trig. They happen with the angle. And so the horizontal shifts are typically going to show up in parentheses trapped with the x. They're also a little bit harder because they get calculated just like a factor, which is to say, if I were to ask you what the answer to this question was, the answer is not what you see. It's not a -3. It's not a reduction of 3. Rather, the answer is 3. And that's a positive 3 as my answer. Likewise, when I'm looking at these horizontal shifts, a little bit counterintuitive, but a plus means move right. Just the same way when I had that, plus means move left. Just the same way when I had that minus there, I got a positive answer, and a positive usually means to the right. Negative shifts show up as positive parenthetical additions. So this would be a move left. Is everybody see where I'm getting that from? So the sideways or the horizontal shifts, you move the opposite of the plus minus operation that you see. For a vertical shift, you move in exactly the same direction as it told you to. Plus is up, minus is down. All right, finally, these last two are a little bit of both, and I've kind of combined them in there. You are going to see at least one or two like this tonight. This is a horizontal shift. I've just blocked off K. I'll undo that. Horizontal shift up or down by K, combined with a vertical shift up or down by C. And the same exact graph for cosine. Now again, if you didn't write this down, you can print this whole sheet out tonight. Just go to my webpage, it'll be there. So let's go ahead and see how we're going to do this. In order to get the job done effectively, we're going to do a lot of pretending. This is Pretend Play 101. And what we're going to pretend is that we can move the axes anywhere we want. When we have a vertical shift, we're going to move the x-axis up or down according to that shift. That move is called the midline, and it's an equation for a horizontal line, and the equation is always a y equals, and it's always this number. That's my midline, and when you have a vertical shift to do, it will always be the first thing that you do. Once you've decided on that vertical shift, you just draw it. So I'm going to go to a height of 4, and I'm going to put in a new x-axis, and I'm going to pretend. I'm going to pretend that's my x-axis, and I'm not going to look at the old one. So as far as I'm concerned, from this moment on for this graph, that's my origin. Is it really? Nope. But when I'm talking 0 high, 0 low, this will be the 0 that I'm talking about, this axis right here. Everything else you do is the same. So I'm still going to do the amplitude. For this graph, the amplitude is a 3. I'm still going to do the frequency. For this graph, the frequency is a 2. I'm still going to calculate period with 2 pi over frequency. So for this graph, my period would be pi. And I'm still going to calculate a move to the right interval by taking the number I just wrote down and dividing it into 4 units. So my interval will be a pi over 4, which we decided last block is typically blocks and a half. You ready to go? So I'm going to start with the pattern 0 high, 0 low, 0. That's a positive sign pattern. And I'm going to start on my positive y-axis. Remember, I'm going to the fake origin here, not the real one. And I'm going to go from there. High, box and a half, up 3. Box and a half back to my fake x-axis. Box and a half down 3. Box and a half back to my fake x-axis. Box and a half up 3. Am I going too fast? And then you just finish until you get to 2 pi, which I've just realized I don't have listed here. So I'm going to label my x-axis. And this will be my 2 pi, which I've just marked off. Connect the dots. And then if you wanted to get rid of that fake x-axis, you can see how this graph looks just like a regular sine graph, just raised up 4 units, and it's done. Okay, this next one is a horizontal shift. Keep in mind that minus means I'm moving right. And for this one, I'm moving right pi over 2, which is 3 boxes. So I'm going to draw a new y-axis this time, and I'm going to draw it 3 boxes to the right of the original y-axis. If a horizontal line is named y equals, then a vertical line will be named x equals. So this is the line x is equal to pi over 2. For my purposes, And from this moment on in this graph, that's going to be my origin right there.
So we don't need the negative.
I'm going to have to graph there, but I don't need to deal with it until most of the graph is done. What I'm going to have to do is backfill, and that's a really good question because I still have to show the graph from 0 to 2 pi. But I'm going to start it as if this was 0, and I'm going to move to the right. When I finish everything over there, I'm going to backfill just like I taught you to last block when we were doing negative pi to pi. Does that make sense? Okay. Cosine graph, my pattern is high 0, low 0, high. The midline for this graph is just y equals 0. Midline is always the horizontal middle. So there really is no midline. I don't need that. The only time you need to tell me what the midline is when it's off the x-axis. Again, that one was there because you'll recall just a minute ago I had a different equation and it was a vertical shift. Still good? Okay, the amplitude for this one is just going to be a 3. The frequency for this one is still the number that's attached to theta. So the frequency is a 2. The period is still 2 pi over that 2, or pi. And the interval is still that period divided by 4, or pi over 4. Now it's worth noting that once you've made this shift, you've put in this new y-axis, you don't have to do anything else with this pi over 2. You can ignore it. It's not there. Pretend it's gone. The pretending we're doing is we're pretending this is our y-axis. We don't need that pi over 2 anymore. We've dealt with it. Still good? So now all I have to do is graph. I'm going to start high at 3 on my y-axis. And from there, I'm going to move right box and a half, go back to the x-axis. I'm going to move right box and a half. And apparently I don't have enough graph paper because I had a vertical shift on there and I took it off. So we're just going to go down. We're going to go 1, 2. We're going to pretend it's like right here. I'm going to move right box and a half and go here, right box and a half, and end up right here. I finished my first cycle. And now I'm going to keep going because I have to go all the way to 2 pi. Box and a half, back to the x-axis, box and a half, back down to, where did I go here? Box and a half, back to the x-axis, box and a half, back to here. And I think that should be 2 pi. This is pi over 2, pi, 3 pi over 2. And this is why we always work in pencil, Emma, because I went too far. Now, how do I backfill? Exactly the way I front fill, just follow the pattern backwards, yep.
If this goes 0 to 2 pi, we go from
the real 0
to the real 1?
To the real 2 pi. That's why I just erased Dill. Okay, so now I'm going to be going backwards. Here's all the way across the graph. Low, 0, high, 0, low, 0, high. Where am I going next? 0, low, and that'll happen right here. And this is what that graph would look like if you checked it on your grapher. I feel like I counted wrong here. Box and a half, box and a half. This one should have been here. And then this one would have been here. Anyway. David. Okay, now to do systems, this is page 47 in your notes. Generally speaking, we just want to take these two graphs that they've given us. They're asking me to do the graph of 2 cos x followed by the sine of 1/2 x on the interval from 0 to 2 pi. Now, at the risk of really throwing you off into left field, I'm going to do both of those graphs without showing my work, just so I can show you what the intersections, the solutions, the systems looks like. So the graph of 2 cos x is going to go high, 0, low, 0, high, and look like this. And the graph of sine of 1/2 x, yep, is going to look like this. And I should label them both. Now, essentially, there are 3 different questions that they can ask you about a graph like this. And here are the 3 different